So I talked a little bit about the time cycler node in the cuttlefish tutorial, and I think I did a pretty terrible job of explaining it. So I think it's actually a really powerful node in the schematic, and it's actually pretty easy to use, but it's a little bit confusing to understand at first. So I'm going to go through that here fairly quickly, and we'll see how the time cycler node works. So I've got a hippo here, right? Mr. Hippo from the content directory. And we'll say we set a key on Y and then go up to like frame 20 and move him up on Y, and on frame 40, he's just back down there. So we have this motion. It's a little cycle, right? We could cycle that, or we can repeat it, or whatever, but we have a motion in our scene that we want to repeat. But I want a little more control of it. I don't want to screw with the channels on this hippo. I want a little bit higher level control over the duration and maybe the amplitude of this motion. So let's take a look at the time cycler node. Okay, I'm going to bring in the hippo, and we'll bring in his Y position as well that we just messed with. And under add channel modifier time, got the time cycler right here. And this has a number of channels in it, and they're not all over here in the channel list. But we can put these in, so we know our cycle here is 40. We've got 40 frames there. And our completion percentage, what is that? An in behavior, so that looks interesting as well. And we also have these other channels: input value, input matrix, output value, and output matrix. What are those? So let's take a look and see what those are. Right now, our hippo has a Y channel animated, but what I really want to do is feed data into this Y channel from the time cycler node. And so instead of having animation being contained on this Y position channel here on the hippo node, or the hippo mesh, I actually want that information, this information right here, or rather more specifically, this information right here, I want to be contained inside the time cycler. The time cycler has something called input value, and this channel right here we can animate. So if I select them both and I take a look, Y position is in view, and so is input value. I can press S to set a key and input value, and just holding Y position here so I can see them both at once. I'm going to hit S again and again, and then I can drag this up, or actually maybe just copy this from Y and paste it onto input position. So now the Y position and the input value have the same values. It's just a single channel of values, right? So, interestingly, I can feed the output value into the Y position. But if I move my time slider here, nothing is happening. So I have an input value. It has animation on it. But when I move my time slider across this animation, nothing's happening. Why is that? Because this output value is going to output a number, not just based on the input value, but a combination of the input value and where it is along its completion. So the completion channel at 0% gives an input value of 0 and an output value of 0. And as long as completion sits there on 0%, that no matter what I drag, it's just outputting that first keyframe out of the output value into the position Y there. It's not changing. But if I just click and drag, let me do channel haul on the completion channel, you'll see as that drags up to 100, and they're at 50%, we're at the top of our hippo peak, and then on to 100, we're down at the bottom. So we've done this entire cycle there by dragging from 0 to 100. What this means is I can retime Mr. Hippo here. So I can set a key at the completion channel at 0, at frame 0, and at frame, let's say 60, I can say 50%, and at frame 80, I could say 100%. And what we have here, instead of the hippo going up and down, up at 20 and down at 40, we have it slowly going up, hits the peak at 60, and then down rather quickly until 80. And you can also, having set this to repeat, I can maybe just go up another 15 frames and set that to 200%. And as I drag through here, it's going to go up to 50%, down to 100%, and then it's going to do the entire cycle up and down in those 15 frames right there. It's just repeating at the decimal place later. And you can, of course, set that to hold, in which case, if it goes over 100%, it's just going to sit there. It's just going to be stuck there. And ping pong, I'm not sure it'll look any different. Yeah, it's not going to look any different when it's just doing this up and down motion, but if it was going forward, it would now go backwards. An offset repeat is kind of interesting. If I look at my input value, and press F7 to bring up the graph here. Let's say it's just going up at frame 40. Okay, so it doesn't go up and down, it just goes up. So in my completion here, if it at 50%, it's only halfway up, and then at, it might help if I keep this open during the thing here. Actually, that might be confusing because right here on on the completion value, we are at 50%, but I'm not outputting this value right here of the input value. I'm outputting the 50% value of the input value right here. That hopefully makes sense. And as it goes up to 100%, I'm now outputting this value of the input value. And what's interesting with offset repeat, when I go up to 200%, it just adds to that last value, so it's going to continue to go up. So it takes this, and over another 100%, it does this whole thing on top of that up to here, right? So that's how those end things work. The end things, it's a good name for it. The end behavior, also known as end things, for you Modo experts. Okay, so that's kind of interesting. We can do some stuff with this. We can do some retiming and sort of flip things around. What else can we do? Well, I'm going to add a locator to the scene, and I'm going to add a couple user channels to the locator. We'll just call one multiplier, because I already have it typed out, because sometimes I make sure this works before I do this. So there's multiplier, and we add one more called Greg channel, because that's my favorite kind of channel. Also, if you ever wish these were in different arrangement, you can rearrange those in the channel panel there. Now they're flipped. Isn't that awesome? Okay, so locator, we can throw this guy in here and add a couple of, when you do that, when you drag things in here, it adds the user channels automatically. A nice little nicety there. Okay, so input matrix, input value. Actually, what I'm going to do over here in the Greg channel is set some values. So bring up my graph editor, Greg channel at 0, Greg channel at 20, and Greg channel at 40. And we'll just kind of do the same thing we had last time, where 0 and 40 will have 0, and at 20 we'll have like 4. And that Greg channel is going to be sent to a multiply node, math multiply. And both the Greg channel and the multiply are going to go to the multiply, and then the output of the multiply is going to go to input value. So even though I already had some animation here in input value that's being animated, that's actually being overridden by, if you look at the channels here, it's got an input, this little gear. In fact, if you hover on the gear, you'll see, what's hard is hovering with a Wacom tablet. The blue there, blue gear means it's driven. So it's driven by a modifier. So even though it has a value, it's being ignored because it's being driven by a modifier. That modifier being this input right here. So what's cool now is if I look at my completion, we just delete my completion animation here. Let's do a completion 100% at frame 80. How about? So let's do 100% here. So now I've got a completion going 0 to 100, but I also have a multiplier value. So I can actually go to my multiplier and say, I want that guy to go twice as high. So I'm going to say 5, or 5 times as high, rather. And now my hippo goes 5 times as high. I have control over the rate at which it does the loop by the completion values. I can go halfway up. I can put any frame I want to. I can ping pong it back and forth. I can do a sort of staggered move where I can set a frame here and then drag it this way. Now it kind of goes up really fast and then goes down really slow. And I can also change the multiplier. I can change the magnitude of that value. So if all of a sudden I've got a fair amount of control in here, you can imagine if I'm controlling something like, a walk cycle or something like that, you can control both the timing and magnitude, the length of the steps and how fast they're stepping, so to speak. And with the repeat options, you could set the completion value to over 100% and have multiple steps, so that you can kind of see how that would work with walking. So there's one more thing here, before I move on to something more complex that I wanted to make note of, and it's something that I did a lot in the cuttlefish rig, and I also did quite a bit in another number of fish rigs, sharks and things that have cyclable swimming motions. And that's, what if, so right now I have my completion going from 0 to 200% at frame 50. So, the Greg channel is doing this over 40 frames. So it's basically up, down is 100%, and then doing up, down again, because this is set to repeat, is 200%. So I get 2 bounces, 1, 2, and the 50 frames that this completion channel is animating to 200%, right? 1, 2. Okay, interesting. But what if, I just want to tell this cycler, I just want to tell this hippo how many frames I want you to cycle in. Some guy says, look, that hippo's got to do his cycle in 47 frames. That's how many frames that hippo has to do his cycle, period. That's the law. All right, fine. So, and this may change because, people tend to change their minds all the time in this business. So I added a channel to my little locator here called number of frames per cycle. Let's change that to 47 or something weird. And inside, and now what I'm going to do is I'm going to add a couple of things. So I'm going to add a time node down here under time. Whoops, add time. And then I'm going to add an expression node under channel modifier, other expression. I almost wonder if that should be under math. Shouldn't it be under math? Is it here under math? It is not. Kind of seems like it should be under math. Anyway, I digress. Expression. So what are we going to do? Well, if we do the number of frames per cycle into input A, you remember how expressions work, and time I can output either the time in seconds or I can output the frame, and I want the frame. Put that in B, and then I say the expression is going to be, I believe, B divided by A. There's a 50% chance I have that backwards. Let me think. So B is the number of frames I have in the cycle, and or A is the number of frames I have in the cycle, and B is time. So right now I've got 47 input into number of frames I want in the cycle. And when time gets to 47, what I'm going to have here is 47 divided by 47 equals 1. And that's going to go into the completion mode, the completion channel right there. If we're halfway to 47, let's say 23 and a half, I guess, 23. At this point, I want my total, which is B, my time, 23, divided by the total, 47, which is 0.5, which is about right. 23.5, but very close to 0.5. So I put this into completion, and I go through here. I've got, let me kind of pull back a little bit. So about 23, I'm halfway up, and 47, I'm done. So there's my cycle in 47 frames. And if some guy comes up to me tomorrow and says, I need the cycle in 96 frames, I screwed up. Okay, fine. 96, that's all I have to do. There, you did it in 96 frames, on the dot. Genius. So with just a couple of nodes piped into the completion mode, we can handle how many frames we want this whole thing to happen. Of course, I can always adjust my multiplier here whenever I want to make things go bigger and higher and better. And then if you really need to go in and change your animation, you can always go into the Greg channel and change your animation. And this setup can be used for a lot of situations. For instance, let's say I've got a curve in here. Let's unhook the Y from our little graph here, and I'm going to attach Mr. Hippo to the path. So now he's on the path, and the path constraint curve has a set of some channels here. One of them is called path percentage. That sounds intriguing. Let's add that to the schematic. We've got path percentage here on the hippo right there. We don't really need the hippo to be in there anymore, but that's fine. So there's percent, and we've got an output value going into percent. Okay, so now we're controlling this percentage along the path with our time cycler node. We've got to be a little careful because if I look at my Greg values here, this isn't a very appropriate value for a curve, right? 0 to 4 to 0. Really just 0 to 1 is a good value for a curve. Now, keep in mind that's on 20 now, and so our time cycler has to end the cycle at 20, not 40, which it was previously. What else? We have a multiplier, which doesn't really make a lot of sense with the curve, so we'll have that at 1. But the same sort of scheme will work where I can, now this is all attached to the curve, so I can say I want you to basically go along this curve in 37 frames, and you may think, why would I do this whole rig and with the time cycle node instead of just animate along 37 frames? Well, because this is a procedural way of doing it. If you wanted to change the animation of this hippo without all this stuff just by keyframing it, you'd always have to go back in there and keyframe. You have to go back there and adjust keyframes to have this guy end at frame 37 or 57 or 409 or whatever. And this is similar to if you looked at the cuttlefish rig, I had those rippling magnet deformers going along the frill of the mantle. And those are all hooked up to its time cycler node. They're all magnet deformers running along curves that are attached to the body. And I wouldn't want to go in and adjust the animation of all 6 of those magnets all the time. Who would want to do that? What you want to do is rig up a little procedural control here so I can say, I need those frills to ripple a little faster. And all I have to do is say, okay, instead of 37 frames for the cycle, I'm going to say 15 frames for the cycle. And then this guy is going to frill faster. So he's just on repeat, right? So that's pretty fun. Also, if you're using, let me unhook this from completion and take a look at the Greg channel one more time. You might want to sometimes have this curve be linear in here because you just want a straight 0 to 1 value, and you want to control all your ease ins and ease outs by animating the completion node. So if you look at the completion graph here, if I have ease ins and ease outs, if I have this completion graph set to curve, then I can control my ease ins and ease outs with this curve on the completion, and I don't have to worry about having some sort of baked in ease in or ease out on the initial animation, because my initial animation here, my Greg channel, is linear. So I can keep that linear, or if I want to with my completion channel, I can do some easing and outing there, or I can just grab the whole thing and go back to linear, and now everything's linear. Yay. Okay, so that's all pretty easy and straightforward. You can hook up channels, you can multiply channels, you can do a little expression with the time node to say I want this whole cycle to occur over this many frames. Those are all very useful things that you can do with the time cycler node. But it can get a little more complicated, and here's another example. I kind of shudder to think this is supposed to be like a Star Wars sort of laser cannon thing from the spaceship parts that ship with Modo, but it just occurred to me that it looks like some sort of high-tech something else. So yeah, get that out of my head. Okay, so yeah. Anyway, this thing pops out. We've got a couple of things going on here. One, we've got we don't have a single value, right? I've got a whole bunch of values. I have a vector. I have 3 values going on at once. So with a time cycler node, let me find my little guy here. So with a time cycler node, add time cycler, we had animated or fed values into the input value channel, which then is computed against the completion time to output an output value. But I've got a lot of stuff going on here. I don't have just a single value. I have 3 values, x, y, and z. So what do? Well, I can use the matrix. Enter the matrix. Did not just say that. Okay, so matrix. We got an issue, though. This isn't a matrix. This is a vector. Vector is not a matrix. A matrix is a list of vectors or a list of lists. That list could be a vector. So we've got to do a little bit of node work to get this to work. And there's a couple of things going on here. With the input value, I could actually just bring up my graph editor and start keyframing the input value, but I can't keyframe a matrix. I've got to give the matrix something. I got to input something into the matrix so I can output a matrix. Okay. So this is getting a little more complicated. I need to feed an animation into this guy, and I've already animated this guy. This is just a deform locator that's deforming basically this entire chunk here is going along for the ride. And it's got a bit of animation on it. But I need to feed animation into it so I can control it procedurally. So I don't want it to have, I don't want these animated channels to exist on this. I want it to exist on something else. Previously, I just copied those into the input value, but here I'm dealing with a vector. I don't have a vector. I don't have XYZ values on this node. So I need to add a locator to the scene, which you can do by pressing L, my favorite keyboard shortcut. And since this guy is called the hatch transform left, we'll call this hatch transform left TC for time cycler. Or I can hit return and it just gives me nothing. Hatch transform left TC. Give it to me. There you go. Okay, so I don't need this. Actually, I do kind of need that. So here's hatch transform left TC. And here is my hatch transform left. I'm bringing up my graph editor here. Hatch transform left TC. I've got what's going on? I have no position values here. So one thing you have to keep in mind is Modo adds those dynamically. So if I look at this guy, I've got no position values there. I've actually got to add those guys. They're added automatically if I start moving them around or add a keyframe, but if I don't move it, if I just add it to the scene, I need to add those manually to get them into the schematic. So there's that. And so let me bring my animated locator back up, and now I can say, okay, now I get it. I have these guys, I'm going to copy them, and I go over here, I'm going to just Shift W to lay down a keyframe so I can select it and paste the other keyframes in there. I'm not sure if you still have to do that. That may be an old Modo thing. Can I just, with nothing there, can I hit paste? I can! So you don't have to do that, make a keyframe and then paste it. You just paste it. So, okay, so this is interesting. I've got my hatch transform TC there, and I'm going to use Cristobal's amazing little script here to make this look different. I'm going to make this purple. No, I'm not going to make it purple because everything else is purple. I'm going to make it green and make it a circle and just a circle and on Z. No, X. That's good. Okay, so here he is, green circle right there. And the green circle has animation on it. So you'll notice if you look in here, these animations are not perfectly matched up. And that's because this guy, whom we will be feeding these values into via the time cycler node, is dynamically parented to this guy. And that is not relevant right now. We'll deal with that in a minute. But that's, if you notice, that's one reason these are off. Okay. So let me maybe do this the easy way and add another locator, and we'll call this height transform TC. And this is going to be doing what this guy is doing. So again, I can bring in my graph editor, and here's the XYZs of this guy starting on frame 2, and my locator, my time cycle locator, I just need to paste those in. Whoops, I need to add my positions and then select them and paste those in. So now you'll notice this guy is going to be going up with that guy. So again, why don't I just make him a green circle, just for easiness, ease of something. And okay, there we go. Actually, this guy, I don't need him solid. There we go. Okay, so we've got a couple green. Kind of hard to see, actually. Go wireframe. Let's go wireframe. Okay, so this guy is dynamically parented to this guy, so I can do that. So why don't I select one, I select the other, I say add parent, and he shoots off into the ether. Why did that happen? Because I did not have compensation. I'm trying to compensate for something here, as you can tell by my model. No. Okay, so I have compensation active and add parent, and hey, now you'll notice everything's kind of matching up. That's looking good. So I've got this guy. I'm going to go ahead and bring him down into the schematic. I don't need to see all these dynamic parents. They kind of come in automatically, but we can remove nodes. But what we want to do is bring in this guy's, even though we already have animation there, we're going to be overriding it. So add in his, Look at that, it brought that back in. Son of a... Oh, okay. Move node. All right, so now we're getting close here. I want to output this guy's XYZ. Maybe if I do this, it won't bring that dynamic parent in. I want to output this guy's XYZ into the input matrix, and then output the output matrix into this XYZ, and then I can have all my time cycle or control goodness in here to control this guy going up and down, and the same with these two here. So, so this whole cycle goes from 0 to 35. So on my time cycler, cycle in 35. And now I've got a problem. Why no, I can't plug this into the matrix. I've got to somehow turn this vector into a matrix. Okay, fine, I can figure that out. We've got nodes, that's what nodes are for. Everybody's been wanting nodes forever, now you got nodes. So congratulations, nodes. Matrix construct, sounds like a good node. Okay, it's got 3 dots here, 3 dots there. That sounds like, looks like a vector to me. It's a nice little icon, by the way, for a vector. It's a list, and that's a list of lists. So we got our vector here, and we will go into our vector, and then we will come out of our matrix construct and into the input matrix, and then our output matrix is going to go, what? I need to somehow make this output matrix a vector to go back into our vector. So matrix vector sounds tantalizing. Output to input. Hey, look at that, X, Y's, and Z's. I like that. And we'll go into our position there. Okay, so we are not done, though, because witness. Something is really weird going on here. What's going on? First of all, where'd this guy even go, right? He's right here at the bottom. He's going nowhere. He's going up because he's dynamically parented to this guy, but basically the animation's not making it through here. So why is that? Well, let's take a look at our nodes a little more in depth here. We've got a matrix node, matrix type position, position scale. We got 2 things. Position sounds good. I'm going to keep position. Okay. Now when I look at this guy, I look over here and I say on frame 5, I've got Y at 674. I look over here and I look at the channels and I see 674 on Y. Okay, that's looking good. It's going into the input matrix. Some weird something or other is happening here, and then something's being spit out. I look at the output matrix. And I have 1. What is that? That is not 6.74. That's a 1. That can't be right. Why is it doing that? Well, what sort of options do we have? Row, Y. Y indeed. I have no idea what that means, but I do know I want translation. So I turn that back to translation, and now I'm getting everything and not just Y. Or maybe that wasn't even Y. And now my guy is in the same place as my purple guy is in the same place as my green guy. Almost. Not quite. It's in the right place, but there doesn't seem to be any animation going on. Why is that? He's only in there in 0. All right, the completion node. Completion node. If I drag this, you see it going, right? So completion node's got to go. So completion node, we'll just keep it at 0 here. And set a key, and then we'll go up to, I think, 35. Of course, we can make it whatever we want, but our original thing was 35, so let's just keep it there right now. 35, we'll call it 100, so we should be sort of matching the original animation basically right here. And you see that we're off a little bit here, and part of that is because, and this is what I had mentioned earlier, I've got some ease ins and ease outs here in my completion node that are different than the ease ins and ease outs that I have here. So if I actually make my completion node, completion channel, not a node, it's a channel. If I make that linear, that should actually probably match up now, and it does. But what? Why is that way up there? Why isn't that here like this guy? I mean, it should be, it's not right. So this is an issue with Modo's setup. It's not an issue, it's just how Modo's setup works. Right now, if I go to setup mode, things seem to be in order, except look at this side. He's right there, but this guy's way down here, and this guy's way down here. If I go back, if I take myself out of setup, the side that's working, everything stays the same. The side that's not working, these guys move up here, and this guy moves up here. So what's happening, of course, is in setup mode, Modo's deformation, and this is being deformed. This is not being parented. This is actually, there's actually a deformer on this guy. and I did this on purpose to kind of show how this works. This mesh here, hatch mesh, is being is part of there's a deformer going on here, and this is the transform weight. That is the effector, the hatch, and here's that side, the this guy right here is our effector, and then there's the deformer, and then the hatch provides, there's a weight map on this hatch. You can see here that this effector, this purple guy, is keeping track of. So the purple guy is deforming this, and by deforming it, I mean it's just all the weights are the same, so it's just moving it around. And our purple guy is matching our green guy, so we can now control purple guy with the time cycler node via the green guy, but our deformation is off. So we need to get our setup mode correct for these guys. So this is a little, you just have to be wary of setup mode, and know that when you see weird deformations like that happening, it's probably an issue with setup mode. So I know that in non-setup mode, my green guy here is at these values, and in setup mode, he's at 0. So I know I want to select these and right click and say apply to setup. And so now in setup mode, I've got green guy there where he's supposed to be. So green guy is now working. It's there in setup and non-setup. Purple guy is still getting some setup weirdness. Now if I look at purple guy, his translation channels, position XYZ, are being controlled by this vector we set up, right? Time cycler node. And position Y, if we go out of setup mode, is at 6.74 at frame 0. Good old 6.74. But if I go to setup mode, I'm getting 0, 1, 0. Out of setup mode, -9, 674, 0.581. So we have some problems here. Why is my setup node, why are these values different here in scene mode than setup mode? I need to get my setup mode to match these values in scene mode. I need to get purple guy down here, up here in setup mode for this to work, because when he's up here and I come out of setup mode, then there's no difference between frame 0 and setup mode. Then there's no delta. That means this guy's not going to be offset or deformed. But since there is a delta, a difference between setup mode down here and non-setup mode up here, this guy thinks he needs to move up. So that's what's happening. That's a long way of saying that's what's happening. Okay, so what do? We just have to go through here and take a look. Setup mode, setup mode. These channels look correct. Time cycler, setup mode. I know that actually is changing if I go to scene mode. Now this isn't the problem, but I like to have everything set up correctly. 35. Completion of 0. And both of them, that looks good. So if you just flick between setup and scene, you can see the differences in the channels. If I go to matrix vector here and I go to setup, what? That matrix row thing. Well, it's supposed to be in scene mode translation. Remember, originally it was set to row Y, which, what the hell does that mean, right? But we changed it to translation to make it work, to get all three of these values over here. But I only changed that in the scene. So back here in setup mode, it's still row Y, and that's a very important thing to keep in mind, is that all channels have a setup value and a scene value. It doesn't matter if it's not a number. Any channel value can be different in setup or scene as far as I know. So you got to make sure these guys are the same in setup as they are in scene position. That's good. Okay, so now setup, this guy's back up here. And I go out of setup and voila! He is in place. There's no delta between setup and frame 1, and everything is working as it should. And what's great is I can go to my completion here and make this, let's say I just drag right mouse click and drag this over to 75, and he's going twice as slow as the left now. So you can imagine that if I were to go here, and I'm not going to do this, but if I were to set up this side, if I were to set up every single each one of these animated guys here, I think there's 5 different animated locators. I would need 5 new locators in the scene, 5 sort of dummy locators to feed their values into the time cycler. But at the end of the day, I'm going to have 5 time cycler nodes, and in this scene controlling all the animation in here. But I can have that one expression I used in this scene right here in one number of frames per cycle channel user channel, and I can drive this entire animation and tell every single one of these guys where to end on or how long this entire cycle should be. And I could do that all with just one channel. So I could go back and control this multiple objects and multiple, not just values, but multiple vector values with just one channel, one user channel feeding into an expression, which then feeds into all 5 completion channels of the 5 time cycle nodes for each of these 5, each of these 5 animated locators in here. So this entire animation that is incredibly amazing, I know, can be done, controlled, rocked back and forth, scaled, whatever, with just and set to a very specific number of frames for a cycle, just with one time cycle node. So this type of thing, it seems like it'd be really useful in gaming, and I'm guessing it is. I do not do gaming assets, but it seems like it should work there. Actually, that's not true. I do Unity assets that aren't really games, I guess. They're more for exhibits, but same type of thing. So hope that is a better explanation of the time cycler node than the crappy one I gave in the cuttlefish overview.